Good morning, Honors Physics. Hope you guys are having a good day today so far. So I'm going to go ahead and do an overview of our Synchronous Day lesson, and we'll just jump right into it now. So as far as things go today, we're 826, 827. So A group is going to be synchronous on Wednesday, B group is going to be synchronous on Thursday. Okay, so as far as getting started with things today, notice we have our reflection form, and you guys want to go ahead and make sure you get that done at the end of the class for attendance. And we're also going to work on an assignment today called the sense of scale and Fermi problem. And this particular assignment is going to be a collaborative partner assignment. So only one partner is going to turn the assignment in. The other ones will have it missing, but then if you have your names, all of your partners' names on the one being turned in, you'll be good to go. Okay, so that's a basic overview of what we got going on today. We've got our planner here, it kind of explains that in the Synchronous Day lesson. And we're also going to review our math pre-quiz next class. Okay, and we're going to be working with partners today. So today's a big partner group day. All right, now as far as things that are due today, so for the synchronous class, we're going to have the sense of scale and Fermi problem, and that will be due today. And so make sure you get that done. And we were looking for our overall goal for the week of 440 minutes, so it's like 110 minutes for today. All right, so Synchronous Day lesson. We're going to start the class today by having you guys present your This Is Me presentation. So I'm just going to have maybe like 2 people present today. And so we'll just get in a pattern of like every day we'll have a few people present, and this will just go on for a while and let us understand and learn who our partners are. We're also going to then review our math pre-quiz and review our measurements assignment. And so I'll do that in class with a review, but there's a few issues here that we want to think about. And there's also the answers right here. So if you somehow missed today, the Synchronous Day, you guys could do your own review here. And you really should put some focus here on studying this material, because this is going to be the basis of a quiz we're going to have next week on Monday, Tuesday on the Synchronous Day. The same thing is true for the measurement practice quiz. This particular assignment, you will want to get on top of this and study this, because we will be seeing this again as far as the content on our quiz coming up next week. And here's the answers for you. So go through and check your work with your partners today and just notice the answers and see if you have any questions. All right, so the next thing we're going to do then is we're going to jump into this concept of estimation here. And we're going to be looking at a Fermi problem. And so notice that we have got the Earth right here in this picture. And there's a question that says, if you could say that the distance from Los Angeles to New York is 3,000 miles, based on what you know about the picture of the globe right there, could you estimate the total circumference of the Earth based on that? And down here in the solutions, it shows you the solution for that. So go ahead and use that. All right, now we're going to be doing this sense of scale and Fermi assignment. And so you'll want to go ahead and get this with your partners and load it up on your computer and jump into it. So let me just kind of show you how that works. And so in Classroom, you're going to see the sense of scale and Fermi assignment. And in your assignments, this is going to be a document that you can type into. So it's one that I've made a copy for every student. Okay, now once you open up that, you're just going to have one of your partner groups is going to write down all of the names of the people in your group. And then as a group, you're going to collaborate on this assignment. And you want to choose this link here that says Scale of the Universe. Okay. And see how it says click to enable Adobe Auto Flash or Adobe Flash. You're going to want to do that. But if it doesn't work, if you can't allow it, it's probably because it's blocked. And then if you go up to this bar up here, you'll see in the corner, there's like a little red icon right there that says it was blocked. And then you can go through there into settings and then unblock it. And then you'll want to open up the program and you're going to play with the scale of the universe. And so things that we're noticing, this idea of order of magnitude, this is in the order of magnitude of 10 to the 0. It says this in the bottom right-hand corner. And these are objects that are in that order of magnitude, like you. Okay, and so if you want to know something about these objects here, you just go ahead and you click them, and it'll tell you the order of magnitude, tell you its rough size, and then tell you some stuff about it. So this is the first part of our assignment today. You just want to play with your partners with this assignment and then stay in the mid zone, zoom down to the subatomic world, to really small things, and notice how the order of magnitude changes, and then get out into the big world, like far up into space and things, and notice again how the order of magnitude changes as you get further out. And then you want to pick 6 items to analyze today and just get a sense of like how big, how vast is the universe really, and how do we fit into that whole thing. Okay. Now, if this program isn't working for you, I put a YouTube link that just has someone going through the program where you could actually use that for this assignment. Not nearly as fun though, so try to get Flash working. Okay. The next thing you're going to do is an assignment called the Fermi problem right here. And the way the Fermi problem works is we have this guy named Enrico Fermi who worked on the nuclear bomb program, that Manhattan Project that led to us developing a nuclear bomb in World War II. And he was a really smart guy. And one of the things he was known for was when he would be with groups of friends and they'd be sitting at like a cafe or something, he would want to come up with like a big question, like have a bunch of these examples down here, and some of them are probably not as profound as he came up with, but like a question like how many bricks are there in the average American city or something like that. So it's like a big question. And he would go ahead and go through a process where he just like did estimations and orders of magnitude and collected information that seemed kind of obvious. And he would do these things called a process called a back of the envelope calculation. And that was literally like you take an envelope that just was sitting on the table and you flip it over and just start doing a bunch of calculations and then figure out an answer. And Enrico Fermi was really famous for coming up to really precise answers through this process. And this process of estimation and approximation is what I want you guys to practice with your partners today in this assignment. Now, I gave you an example question here that says, how much does a standard cumulus cloud weigh? And so it shows you the process of making a wild guess and then making an educated guess by guessing out some numbers that are more accurate and crunching them together. You come up with a calculation approach of how you're going to go ahead and solve this problem. What are the things that you're putting into your equations? What are your assumptions, basically? You're going to gather information. You can use the internet for that, or you can just use background knowledge if you have it. And then you're going to come up with an estimate and then compare it to what Google thinks. And that's our process for how to do a Fermi problem. And it goes through one problem there, gives you the directions, gives you the format of questions, gives you a bunch of example questions you could use, or you could come up with your own, and then gives you, you're going to type into this document and do your own Fermi problem right there. Now, again, this is going to be just one per all your group, and you guys can go ahead and share this information. You can collaborate, look with a Google Doc, and then bring all the information in if you need to, but just one person turns it in, and don't forget to put all of your names at the top. Okay, so that's the Fermi problem, and that's how we're going to finish today. And then the last thing to do is just fill out the daily reflection form, and then you're done. You guys have a great day.